Okay, hello. Right, today we're going to be doing TCP IP and the application layer protocols. So we're going to go through the TCP IP protocol stack. Now, what I suggest you do first is you watch these two videos here. Okay. Now, it talks about the OSI map. Yeah? So watch those and then we'll come back and I'll explain. Welcome back. Now, the OSI is not on the syllabus, so you don't need to worry about the OSI. It's something that is used in networking terms, but we only need to worry about the TCP IP protocol stack. Now, in the very first video, he makes a very good case for why we need protocols. Okay, it was so that we could have different machines running, connecting to each other, and not having to worry about how they actually work. All right, so we can just use the same protocol, so your Android can connect to Apple and stuff like that. All right, obviously it was different back in the 70s when it was discovered. Right, so how are we going to do that then? Right, okay, that's the first one, the TCP IP protocol stack. Now, it's application transport network and link layer. Now, there's also the physical layer, which would go underneath, but as I say, we don't really need to worry about that. That's hardware. Now, how do you remember that? All tanks need love. All right. You notice it's sometimes called the data link layer, and in his videos. So that's the way I remember it. You can replace T with something ruder if you want to, but that's fine. Now, so how does it work? Well, he does do a good job of explaining. I will also do the same video that he packet tracer that he did. Now, the packet tracer that is there if you want it to have a go yourself as well, but it is pretty good. All right. Now, so what is a protocol stack? Well, it's basically modules, if you like. And if you want to send something, you go down the protocol stack and you add more and more things to your data. So if I want to request a web page, then my application makes a request. Okay, and then it then passes that application down to the transport layer that adds some more stuff on. Then the network layer adds some more stuff on. The link layer adds some more stuff on, and then we can then send it out on our network. All right. And then when it finally arrives at where the destination is, be it the web server in this case, it then strips off each layer, and then we finally get to the actual program it wants to deal with. Now, this picture here kind of shows it. Now, these two there don't apply to us. All right, physical we're not even interested in either. All right, but you can see as the data is passed down. I need a different color here. As the data is passed down, going down here, it builds up more and more information until it's finally sent. So it's a segment, packet, and frame, and then as it goes back up the protocol stack towards the application. Now, I'll explain that in more detail now with packet tracer. Okay, but let's have a quick look at what the notes say about that. So the first one is the application layers at the top of the stack. So we have an application layer protocol, HTTP, POP3, FTP. Now they are how applications communicate. All right. So when your web browser makes a request to a web server, it uses its own protocol, HTTP. So things like GET. So it wants to get a web page. So there are ways that you access the web server. So that's what the application layer deals with. And if you like, the application, let's make that a bit smaller here. Some sort of diagrams, you'll see them talking to each other like that. So the application layer talks to the application layer, if you like. The transport talks to the transport and things like that. All right. So that's the first thing, and they're different ones here. So we have HTTP, HTTPS, POP. Which we'll see later is post office protocol used for mail, FTP used for transferring files. All right. Now, one thing to remember, the transport layer. Remember the word port. transport. Okay, that will become useful later. Now the transport there puts on port numbers, and they identify a particular process. All right, so for instance, if a packet arrives here, I say packet, with port 80, then what that means is that the machine or server says, okay, port 80. Now, anything coming from port 80 from my transport layer must be sent to the web server, because everything port 80 is to do with web servers. All right. If it was port 21, then I think that's Telnet. I could well be wrong. We'll see in a minute. All right. So that identifies a particular process. Now, there's also a source and destination port number, which we'll talk about later as well. All right. But the transport layer, think of ports. It also, it says about TCP. Well, if I could write, that'd be good. TCP, transmission control protocol, and we also have UDP, which is less reliable but faster. And I can't remember the name of UDP, what that stands for at the moment. All right. Now, the other thing that the transport there is, we will break it up into packets. Okay. So if we're doing a request to a web server, then it's not going to be a massive amount of data. It could maybe use one packet. But if the stuff coming back from the web server is a lot of data, which it could well be, then it will have to split up into lots of packets, and the transport layer will deal with that. Okay, so the transport layer, then the network layer, which is level 3, layer 3, layer 4, and 5, 6, and the application layer is layer 7. All right. You don't need those layer numbers, but it'll just be clearer in terms of the video. Now, the network layer, what does that do? Well, if you remember, one thing here is IP addresses. Sort of a lot of the questions we'll talk about, explain what each layer does. Right, so what we have then is we have our data. There's our data. We have our port numbers added on, and then finally, well, not finally, but we then have our network layer. So what it's doing is, you notice it's encapsulating. You can see that this completely included. He talks about envelopes in his video, which works quite well. All right, so there is our IP addresses encapsulating that, and then within there we have our port number, and then within there we have our data. Now the next layer is layer 2, is our link layer. Now that's to do with our MAC addresses. So this will add on our MAC addresses. Okay, and this is to do with what's called a hop to hop. So this gets our frames. Remember, this deals with packets, and these become frames when we add on our MAC addresses. And this gets us from one machine to the next machine. So you can go from machine to router. So you have a PC here, PC, machine, computer, whatever. Then we have a router. So that's a hop from there to there. Then it might go from another router, have choices of many routers, but it shows that one. So then it went from another hop from there to there. And then finally that router is connected to the server. And then it's finally another hop. Now the important bit to notice here is for each hop, the MAC addresses change. So it has the MAC address of this machine here. Okay. So it'll be the MAC addresses of this one, the MAC address of that one. So it'll be the source. That'll be the source to get from there to there, that frame from there to there. It'll have the source MAC address of this machine and the destination MAC address of that machine. To get it from that hop, it will have new MAC addresses, source being this one, and then the destination being that one, and so forth. So as it goes through the networks, for every hop the MAC addresses change, unlike the IP addresses. So the IP address here, that's the source IP, and then we have the destination IP there. That remains the same throughout. Okay. Now what this shows here, this diagram, is this. Not very well. It shows now we have encapsulating it with the MAC addresses as well. So there is our frame ready to be sent. So it has, that could be the source MAC address, destination MAC address, source IP, destination IP. Okay. Now what this doesn't show is it doesn't show the source. So that will be the destination IP MAC port number. It's missing, so it needs a source port number, which I'll show you in a minute. So that will be in there as well. It doesn't show it on here, don't know why. Now it talks quickly about media access control addresses, MAC addresses. So those are on every network interface, be wireless or wired. All right, so it's a 6-byte number. 1, 2, 3, 4, 5, 6. So 2 to the power 48, whatever that is. It's a lot. Okay, so no need to worry about that. Now, when I talked about port numbers, there are well-known port numbers. So yes, no, I got that wrong. So port 21 is FTP, it's for transferring files. Telnet is a classic. It's probably turned off on your computer because it's unencrypted, so anyone can just sniff the traffic that you're sending there. SSH Secure Shell Remote Login is like the better version of that. All right, so that uses encryption. And then 80 classic, and then the example we're going to look at in a minute is 443 because we're using HTTPS. All right, so okay, now let's have a look at an example. Right, so I'll do exactly the same example that he used. I have no idea who that is supposed to be. So you click on the person there and then go to web browser, and I'm going to type in network.coffee, except I'm not going to type it because that would take ages and I would make a mistake. Right, so that's what I'm going to put in my browser. So what it's going to do is going to go from this machine on this network. Now remember, routers separate networks, so it's going to go from this network to another network over here. So the router separates this network from the one over here. Now it's simplified because there will be many routers that this will be connected to, possibly. Now I've done the edit filter, so I've got rid of ARP, DNS, and ICMP. DNS is used to find out domain name server, which we'll talk about later. But essentially, when I put in network chuck coffee, it doesn't, I don't know the IP address of that, but what it will do, the DNS server will know what that URL IP address goes to. So it's the server here, this one here, and it's IP address 23227. So the DNS server will tell us what its IP address is. Now, so let's have a go and see what we've got here. So if I press go, so, and then on here, we'll do that. Now I've got it on, let's reset that because I didn't want it on real time. So let's try it again. So you can see it's actually got it. Let's just go again. Right. So okay. So what we have here is our layers ready to go. Now it doesn't show layer 7 being the application, doesn't show any data in there, which would involve like a get command. Now we have a destination port 443. So that is saying I'm accessing HTTPS on the server. My source port, now that source port is really important. That is just a port number that we need to record, because when the reply comes back, we need to know which thing on our machine requested that. All right, so it could be a tab, it could be a web browser within that tab, so we know where to send it to. So it's just an unused port number that isn't in use at the moment, so it chooses anything that's unused. Whereas 443 is a we couldn't use that as our source port number like 21, because those are port numbers that are used for things. We have IP, so there's that's who it is, and then there's my destination IP there. Okay, so let's close that, and so off it goes to the switch. Now, as he says there, now the switch only looks at layer 2 stuff, so it's just looking at the MAC addresses here, and it's saying I'm going to send it to port 6. Now, when it says port 6 there, it means not as in ports, as in port numbers. It's actual physical connections on the actual switch itself. Now, when it sends it to the router. Now, the reason why it sent it to the router, as opposed to anything else, is because it knew that the IP address that we're sending it to was not on our network. So anything not on our network will get sent to the router. Now, the router, being a layer 3 device, will look at the IP address. All right. Now, what happens is then that the router will then send this packet closer to wherever it needs to go. Now, it could be another router, and I think I have an example packet tracer of one of those, but it could be that. But it could be just to, within this case, it will be sent to a switch, which is the correct device. Now, what that will do now is it will change the MAC address. So it had a MAC address to get it from there to there, and then it will have a new MAC address of that machine there, and that's how it will get it from that machine to that one. Now, it knew that because it would look up the router here, it would look up in the table, it says, right, I've got connected to me, I've got that IP address on that router, on that MAC address. So off it will go, and then it will arrive at the machine. Now, if we have a look at the packet, there we go. So it arrives here. Now it'll go up through the protocol stack. It goes, is that me? Yes, 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 yes. No, we're looking at this side. So we got the source was from that machine. It was going to that machine. Yeah. It would then go right. My destination port is 443, so that is, so I'm running, if I'm running a web server on this machine, then I need to send it, this data that's in layer 7 to that actual process or program that's running, right? So this will identify, so if it came with port 21, which is FTP, then I would send it to that program. So this port number is really important, so it's identifying which program I need to send this data up here to. It's not showing it. Right. Now, what do we do? Well, when we receive that, then we need to reply. Now, we know where to send it to because we know the IP address of who sent it, which was our source. That becomes the destination, and off it goes. So the destination now gets flipped around, the source and destination flip around, and off it goes back again. And off it goes. And seems to be an awful lot more packets going around here, but eventually, I think because I ran it earlier, and then we should find you need to drink coffee right now. So you can actually on Packet Tracer you can set up. I guess there should be some pictures in there as well, but you can set up on the server. You can add HTML, so you can actually do that. Right, so hopefully you can see what's happening there. Now, the important bit to notice is from there to there is a hop. There's another hop from there to there as well. Well, come on, I need to stop you now. Okay, right. So hop, hop. So what changed then would have been the, and true to form, this stalls. Right. Whoa. So this part here is changed every hop. All right, because we get new layer 2, new MAC addresses, physical routers or computers that we have to go from hop to hop. Okay, so the other important bit I think is the port numbers. So we need to make sure that we actually send, when this arrives, destination port 443, it goes, right, okay, I send that to the correct program. Now the other thing is when this is flipped around and it arrives back, the destination port will be, in this case, 1025. Who actually created that 1025? Then we send it to that correct thing. So as you imagine, if you had a tab open in Internet Explorer, in Chrome, then when you've made a request in that tab, you want the actual data to come back to that tab and not to a different tab or a different program on the computer. So we would record that. Okay, now the next part of that, hopefully that is clear, transferring files to FTP. So basically you can use FTP in your PowerShell. So I can do open, and that will ask me an IP address or whatever, and then I can connect to a machine. You can also use the one that's shown there, FileZilla, as a graphical user interface, basically, of that. All right, nothing more you really need to know about that. SSH is using a secure shell. So again, I can use SSH to connect to the command line interface. So I can connect to any machine on the internet and access its command line interface. So you can just do simple, so if you can connect to a Linux machine from a Windows or vice versa, it doesn't matter. Okay, but you'll be using the actual interface of that, or the operating system of that machine. So when you do dir for Windows, I'm not sure, just so that tells you that's the, or if you were logged into a Linux machine, then crikey, then you do ls, for instance, and you could run console apps and things like that. Now, oh my god, okay, I'm regretting that. Okay, so let's just do one more thing here. Now the classic one, and I hope I've got the right, Telnet tal.blink n lights.nl, could be blinking lights. I think I've got to install Telnet in order to do that. It's one of those two, but it is basically Star Wars. It basically connects to a machine that runs is an ASCII version of Star Wars. Telnet not installed. It should be. Yeah. I think like a bit of preparation. Yeah, I think it's. I need to put it on the machine. Right, it's one of those options. I think it is an option within your applications. I can't remember where it is now, but okay. Now, the role of a mail server, sending and retrieving mail. There's a couple of things you need to remember here. You have POP, which is Post Office Protocol, and SMTP. Now, I don't really know you need to know this, but this is Post Office Protocol. So this is used for reading mail, and this is for sending mail. All right, both of those are a bit outdated now, but basically the reason why I remember that is send, S for send. Now both of those are kind of been got rid of now. What the problem is with those was if you read a mail, it would then you wouldn't be able to, it would actually take it off the server to your local device, and you wouldn't be able to see it on other devices. So IMAP is more common now for mail. But there again, just application layer protocols. Now the other thing is web servers. There's a bit of HTML there, lovely. Everyone loves those. There's not a lot you need to say about that, but you know, you could see that coffee video there. Right, okay, I've gone on enough there. I will set you some work on that chapter via Teams. Okay, there we go. That's a bit of a long one.